Hello and welcome to the Marine Tech Corner. Today I'm going to talk about our new lithium battery. I want to make this video as practical as possible, so I've put a bunch of links to helpful videos and other resources into the description of this video. Now first about this battery. It's a lithium iron phosphate battery from a Chinese brand called Frey. It's set up in a 24-volt configuration with around 200 amp-hour capacity. The bank is composed of 16 individual cells with 100 amp-hour capacity and a nominal voltage of 3.2 volt each. 8 sets of 2 are put in parallel, which doubles the capacity to 200 amp-hour. Then those 8 sets are put in series, which multiplies the voltage by 8. So 3.2 times 8 is 25.6. Now that's the nominal voltage. In reality, the voltage will go up and down depending on the loads you're pulling and the state of charge of the battery. The device here on top is called a battery management system, or BMS, which is like a little computer you'll use to configure the battery. I'll show you later how this works. We bought this battery from a vendor here in Germany called Emotion E. The owner was very helpful answering all kinds of questions I had in the beginning, and when I had an issue with the BMS and couldn't get it to work anymore, they immediately replaced it. You'll find a link to their shop in the description of this video. They offer service in English and ship Europe-wide. Initially, we were drawn to lithium batteries mainly because of their longevity in terms of battery cycles. With lithium, you're supposed to get 3,000, even 5,000 or more cycles out of a properly configured battery. There are many other advantages to lithium batteries, such as their compact size and overall available capacity, but I want to focus on longevity here for now. When I said 5,000 cycles and more out of a properly configured battery, I put the emphasis on properly configured. Lithium batteries tend to live longer if you operate them within a certain range of state of charge, or SOC, meaning that you don't fully charge or discharge them at each cycle. Instead, you only use them at, let's say, 90% to 30%. You do this by programming the BMS on your battery and your charger so that they keep the battery within that range. To modify the settings on your BMS, you simply connect to it via a Bluetooth app and put in the values that are right for your system. Changing the settings on a Victron inverter charger is just as simple, only that here you connect via USB to a free software that's provided by the manufacturer. In order to know the right values for your battery, you have to check the data provided by the manufacturer. For our battery, these values are 3.65 volt at 100% SOC and 2.2 volt at 0% SOC. With this, I was able to draw a simple table which gives me the voltage for a given value of state of charge. I then program these numbers into the BMS of the battery and our Victron inverter charger, so that the battery cannot get charged or discharged beyond those voltage values. The next thing you need to watch out for is the profile at which your charger operates. I'm not going too much into detail on this, other than the fact that it's highly recommended to get a charger that has a specific profile for your type of lithium batteries. The third thing to ensure longevity is to make sure you have a properly sized battery bank based on your consumption. If you're constantly drawing currents that are at or above the maximum continuous discharge current of your battery, you're not going to get a long life out of it. For that reason, it's important to size your battery banks according to your power consumption. And to do this, you'll need to set up a power budget. Just a quick note here, I'm doing this from the point of view of a year-round, full-time liveaboard without permanent access to shore power. Simply put, you can compare the energy in your batteries to money in your bank account. In order to be able to spend the energy, you need to deposit something first. Your generator is then like your 9-to-5 job, which would be your main source of income. If you have solar, that would be more like the stock market, but we'll not talk about this today. Now, your minimum power budget is defined by your lifestyle. Just as you can't go and buy luxury cars and jewelry every day on a $50,000 a year income, you can't run excessively high electric loads all day long from a moderately sized battery alone. So how do you make your power budget? First, you need to separate your energy expenses into regular or fixed expenses and occasional expenses. Your regular expenses include everything you absolutely need every day for living, such as your fridge, water pumps, charging for your electronic devices, but also anything you need for cooking or your coffee maker, water cooker and so on. Those are your fixed power costs. Occasional expenses could be things like running the washing machine once or twice a week, power tools to do repairs from now and then, and so on. Then there are certain devices which draw so much power that it would be unreasonable to run them off your batteries, because you would need a huge battery to support them. Those are usually any large resistive loads which you need to run for a long time, such as a warm water boiler, electronic heater, and so on. To run those loads, you just need to run your generator or be plugged into shore power. So once you know what kind of loads you'll use, at what times and for how long you'll use them, you will then be able to determine the size of inverter and battery that's best for you. To get an idea of our power budget, we did some tests with some regular household appliances as we would use them on the boat. Running these one at a time is not a problem at all for the battery or the inverter charger, as none of these draws more than 100 amps on the DC side. And as long as it's only for a short time, like a few minutes maximum, you can get by a very long time with a single battery charge. I managed to get several days worth of usage out of each of these devices, using up only about a quarter of the available power in the battery. Of course, in real life, we'll be running several other loads at the same time, and here's where we need to be very careful. When using several loads at the same time, even if you stay within the capacity of your inverter charger, the power draw can be so high that the voltage drops below the limit where the inverter charger will shut off, even if the battery still has plenty of charge in it. Now, to conclude my thoughts on this lithium iron phosphate battery, I really like the smart element of the battery, that it has its own little computer where you can see all kinds of values and set very specific parameters of use. I also like the compact form and that the shape can be adjusted to some extent. When it comes to the application which we plan to use the battery for, I can already say that we will probably need double the size of what we currently have for our planned power consumption, just to be on the safe side. All in all, I can recommend this battery type and brand from what I've seen so far. Of course, we need to do some more tests and collect some real-life experience, but that's gonna be the topic for future videos. With that, I say goodbye to you, and I hope to see you again here in the Marine Tech Corner for another video.